There is another question for the determination of output noise power. Almost all the question papers have at least one question for the determination of output noise power. This belongs to the fifth module. So comparatively, this particular problem is a lengthy one and the mark is only 5. Here, the scheme of evaluation is equation 2 marks, output noise power 3 marks. A very similar problem we can see in the Ramesh Babu's textbook 7.24 page number. The problem is given. So first you have to draw the noise model, then the determination of the output power for the two different noises independently. Okay, let us try to solve this problem. As usual, given h1 of z, h2 of z, and the overall cascade system function is given by h of z equal to h1 of z into h2 of z, given by this expression. Next, we have to draw the noise model of this structure. Here we have one delay. So first you draw the feedback coefficient 0.5. Then at every output of the product term, we have the error. You can represent as E1 of n. Input x of n. Similarly, we can draw the h2 of z. So we have the error E2 of n. The output y of n. This is the noise model of the structure. The overall noise is given by, output noise is given by sigma naught 1 square plus sigma naught 2 square. That is the noise power due to E1 of n, and sigma naught 2 is noise power due to E2 of n. So you have to independently compute the noise power and add the two. Here we can see the entire system, that is h1 of z into h2 of z, is seen by the error E1 of n, whereas E2 means only this h2 of z. That is, the error seen by E2 of n is only the system function h2 of z. Accordingly, we have to compute the noise power corresponding to E1 of n and E2 of n and find the sum. Here, the overall noise output power is given by the noise power due to E1 of n and the noise power due to E2 of n added. Here in general, the output noise power is given by the expression sigma e square into I, where I is given by this contour integral of this part, and sigma e square is given by 2 raised to minus 2b by 12. So here sigma e square is known as the input quantization noise power, and here b is the number of bits excluding the sign bit. So in our case, the number of bits are not given, so we can continue with this notation b itself. Now we can compute sigma naught 1 square. This E1 of n is seen by the entire system, so that we can take h of z as this is, so that I1 of is given by this expression. Here you can see z inverse is given by this one. Now this contour integral can be computed by the sum of residues inside the unit circle. Now let us compute the poles of this system. Here the poles are given by, one is z is equal to 0.5, then z equal to 0.6, then z equal to 1 by 0.5 and z equal to 1 by 0.6. So here it is evident that the pole at z equal to 1 by 0.5 and 1 by 0.6 are outside the unit circle. So the residue due to these poles can be discarded, will be 0. So we can take only the poles z equal to 0.5 and 0.6. Here the residue due to 0.5 and 0.6 given by, this is due to 0.5. So here z inverse, we are multiplying denominator and numerator with z, this term will become z minus 0.5, so that this term and these terms will cancel. So in this case, this 1 minus 0.6 is done. We are multiplying numerator and denominator. This will become z minus 0.6, so that this term and this term will cancel. Now substituting for the values, this will be 1 minus 0.6 by 0.5. Z inverse means it will be division by 0.5 into 0.5 into 0.5, 0.5 square, then 0.6 into 0.5 plus the term due to the 0.6. So here substituting 0.5 divided by 0.6 into 0.5 into 0.6, 0.6 into 0.6, 0.6 square. Now which is equal to, now substituting and calculating, we get sigma naught 1 square equal to 3.6. In a similar manner, we can compute sigma naught 2 square, sigma e square into I2, where I2 is given by contour integral of h2 of z. We have seen that the error seen by e2 of n is only h2 of z. So instead of h of z, we can replace it to h2 of z. Now we can substituting I2 equal to 1 by 2 pi j into 1 by 0.6 is. Now the poles are at z equal to 0.6 and z equal to 1 by 0.6. Now here it is evident that z equal to 1 by 0.6 is outside the unit circle because it is above 1. So the residue due to this z equal to 1 by 0.6 is 0. Now we can compute the residue due to 0.6, which is given by z minus 0.6 into this term. Here we can see, when this is multiplied with the z, this will become z minus 0.6. So these terms will cancel. Finally we have this term only. So when substituting z equal to 0.6, we get it as 1 minus 0.6 square, which is equal to, computing we get 0.64. Finally we can substitute for sigma naught square, which is given by sigma e square into I naught 1 square plus I naught 2 square. So sigma e square, it is equal to 2 raised to minus 2b divided by 12 into I naught 1 square. So there is a correction. This is not sigma naught square, whereas it is I1. I1 we have computed as 3.6. This is not I2 square, it is I2. I2 we have computed as 0.64. So the equation is sigma e square into I1 plus I2, so which is equal to 3.6 plus 0.64, which is equal to, the substituting value we will get the answer as 0.3533 into 10 raised to into 2 raised to minus 2b, where b is the number of bits excluding the sign bit. Thank you. Sorry, there is a slight error in our computation. So here 1 minus 0.5 by 0.6, we are rounded it to 0.17, which can replace with 1 by 6 itself. So when we are replacing, there is a slight difference in this value. This 13.3 will become 13.3928, 13.3928, and subtracting, we get, instead of 36, there is a slight difference. It is 3.87. That means I1 equal to 3.87. Here we have done a great mistake, because it is 1 by of this one. So 1 by 0.64 equal to, so we get the value as 1.5625. So I2 equal to 1.5625. So this will be replaced with 3.87 plus 1.5625, and summing we get 5.4325. So the final answer can be written as 2 raised to minus 2b divided by 12 into 5.4325. So here we can see the same problem they have solved with the A1 equal to 0.5 and A2 equal to 0.6, which we have discussed at the beginning of this problem, the Ramesh Babu's textbook. So here in our case also it is A1 equal to 0.5 and A2 equal to 0.6. So the answer is 5.4315, and we got the value as 5.4325.